So I'm doing this problem to help you find reference angles. It says find an angle theta with um, its angle between this angle needs to be between 0 and 360 that has the same sine as 70 degrees. So really, if we want an angle to have the same sine as 70 degrees, it has to create the same triangle when we draw a line down to the x-axis. So here's what I mean. Because sine and cosine are the ratios of the sides of the triangle. If there's another angle out there that has a terminal side that creates the same triangle as we get when we as the triangle that we get in the 70 degrees, then with 70 degrees, then we're going to have the same kind cosine and sine. With the exception that we have to have, it has to be either, if negative or positive. So actually, we want it positive here. So let's look at this. First, I draw a 70-degree angle. We want the sine and cosine to be the same as a 70-degree angle. So let's look at what a 70-degree angle looks like. I don't have to be exactly measure this here, but I do know it's between 0 and 90 and probably a little bit closer to 90. So I'll just draw this. Okay, and then now I can draw any circle I want, really. I just like draw a circle. And now from the point on the circle and I down to the x-axis, I draw a straight line that forms a 90-degree angle. That creates this right triangle. The sine is equal to y over the radius. So it's a ratio of those two sides. Sine of this angle, and this is where the 70 degrees is, 70 degrees right here. Now, any other triangle that has this same 70-degree angle with the x-axis here, made with the x-axis, will have the same sine, but it may be it may be negative or maybe positive. Okay. Let's talk about sine of 70. Sine of 70, because all of our this is the regular this is the regular Cartesian coordinates. So recall that the regular Cartesian coordinates, this is as we go to the right, then these numbers get larger and they're positive. As we go to the left, then on the x-axis, these were negative. And recall the regular Cartesian coordinates, as you go down, the numbers are negative. And as you go up, the numbers are positive. So that's the same thing that I have going on in this picture. As we go up, it's positive numbers. As we go down, that we get negative, there's negative numbers, okay? The same thing. If you go this way, these are positive numbers, and go that way, it's negative numbers. So in this first quadrant, we're going to have a positive, all of our values are going to be positive x values. So I'll put positive x from any point in that area. And for any point, both our x coordinate and the y coordinate are going to be positive for all points in this first quadrant. So this first area. So that means that particularly because sine and cosine are your y and x coordinates, if you're on a unit circle particularly, and then you're going to have positive cosine and positive sine in this first quadrant. So I know that sine of 70 is positive. So I need to think about another quadrant that I can draw this same 70-degree triangle that sine, the y coordinate, would be positive. And let's just think about this. This is quadrant 1, this is quadrant 2, and this is quadrant 3. This is quadrant 4. This is going to have positive y values or positive cosine, so positive sine here, and it's going to have negative x values in this second quadrant here. So it's actually the second quadrant, and that will give us if sine of 70 is positive, so our sine of any angle in the second quadrant would also be positive. Notice how in the third quadrant and fourth quadrants, all your y coordinates would be negative because you're below the x-axis there. So it's only the second quadrant here that we can draw this triangle and we can possibly have exactly the same sine as sine 70 if we have the same 70-degree triangle coming off the x-axis. So how do we do that? We just measure. Now, this is important when we measure this 70 degrees, it needs to be from the x-axis. So we're measuring up like this way, we're measuring up 70 degrees. So then it's right here. And then we draw the triangle in. And you can tell I didn't do a very good, I did not do a very good circle because they should be the same height. That should be, maybe I should try to fix it. But you should see here, if I drew the circle correctly, that these two triangles, let me draw them in blue. These should be the congruent triangles, meaning the y coordinate here and the y coordinate there should be the same. After all, they're the same degrees, same number of degrees off of the x-axis, 70 degrees. And they have the same radius, same length of the hypotenuse. So I believe this is an angle. Anyways, these are two congruent triangles, and so their radius is going to be, their sine is going to be exactly the same. Cosine is y over r, and the y over r on this side is going to be the same as the y over r on this side in the other blue triangle. So now we just have the burden of figuring out, well, I need to measure this angle that terminates right here. I need to measure that from the positive x-axis from standard position. So I have to measure from here. Let me get I have to measure from here to there, right? Because we know it's 70 degrees here, but what is it here? And the way to do that is you do 180, because we literally got this 70-degree angle because we came from 180 and we backed up 70 degrees from a total of 180 degrees, because 180 would be all the way across. So you do 180 minus 70, and that will give you the 110 here. So that is the angle that has the exact same sine as 70, is a 110 angle. Because they a 110 angle and this line both make a 70 degrees when you draw it back to the x-axis. When you draw an arc, the shortest arc back to the x-axis, they both make a 70-degree angle. Okay. Well, let me show you that again. 70 degrees and 110 both of them, when you measure from that terminal side to the closest x-axis, both of them are 70 degrees. And so then your height of any triangle drawn is the same, and that's why the sine is the same. Okay. All right, now let's go ahead and do the second part of this. I'll start. I draw so much. Maybe I'll just use another different slide over here. We need to find something that has the same cosine as a 70-degree angle. So again, I draw my 70-degree angle. I imagine a point being, doesn't matter where my point is, I just draw a point and I draw a line down. And then I label my 70-degree angle. So the cosine is x over r, which is, if we're in a unit circle, we can just think about it. Cosine is just x, or cosine of the 70 degrees. So it's just this side. So we need to find another triangle that has the exact same really x coordinate, or side of the adjacent side of the 70 right triangle. So we're to find it, we're going to draw this exact same triangle in the other quadrants, and that's where we're going to find it. It's in one of the other quadrants. So we think about it and we think, oh, well, cosine is this distance here is, and this point located in the first quadrant is going to be positive. It's going to be positive x. So cosine of 70 degrees is going to be positive. So I need to think about what other quadrant has a positive x value. So let's think about second quadrant. Well, if I go left, these are negative x values. So it's not the second quadrant. The third quadrant has the same problem. Any number, any point is going to be like this point right there would be -3, like maybe -4. So it has negative x and negative y. So we think about the fourth quadrant, this does have positive x values. So what I need to do is I need to start at the x-axis in this quadrant, and I need to measure 70 degrees down from the x-axis. And that is going to be the angle that has the same measure as the cosine of 70. So how did I get this angle? You could think about, I started this all the way around would have been 360. So I'm starting at 360 and I'm backing up 70. So it's 360 minus 70, which would be 190. Right? 290. Because 16 minus 7 is 9. And then I had to take away 1 to borrow for the 16, and then that would have been 290. Okay, so this is 290. So cosine of 290 is going to have the exact same sign and value as cosine of 70. And that's because cosine is x, this x over r. And if I draw exactly the same congruent triangle, the sides are all going to be the same. And and particularly the sides are going to be the same, the x values are going to be the same. And that's what cosine is. When you're on the unit circle, it's just your x value. So of these points. the x value of that point and the x value of this point are going to be the same because it's the same 70 degrees off the x-axis. All right. I hope that, and it forms the same triangle, and since it forms congruent triangles, and the ratio of the sides are also going to be congruent, so cosine will be congruent. And not just even congruent in absolute value, but congruent in the sign as well. All right, so the second answer there is 290. All right, well, I hope you found this valuable. Have a great day. Bye.